We are on lecture 11, which is page 43, compound angles and double angle identities, and we will also be tackling trigonometric equations. Now, just quickly about the identity. An identity is a statement which is true for all values of the variable. An equation is a statement which is true for certain values of the variable. Therefore, if you have a problem, someone has given you the wrong identity and said prove that the left hand side is equal to the right hand side, you will fail to prove that if it's incorrect. And what you do is just take an angle, do a special angle substitution, and if your left hand side is not equal to the right hand side, then you know the identity is wrong. Now, points to note: cos of 2x has got 3 expansions, sine of 2x has 1 expansion. Now, in respect of your cos of 2x having 3 expansions, strategically you must look at the some of these identities which have a +1 and a -1. Then you will have a clue about what to use. And then you've got 1.2, it says 1 minus sine 2x is over sine of x minus cos of x, and it is equal to one of those possibilities. I actually didn't want to tackle this problem, but basically 1 is equal to sine squared x plus 1 is equal to sine squared x plus cos squared x, and then you've got plus cos squared x, and then you've got minus 2 sine x cos x all over sine x minus cos x. Then what you do, the numerator is sine x minus cos x times sine x minus cos x, and the sine x minus cos x will cancel off, and then you've got sine x minus cos x is your answer. Then the other question that typically comes in is for what values of x is the identity undefined. It is clear that the restriction that applies will be to the denominator, that sine x minus cos x, if it's equal to 0, then the identity is undefined, and then we say sine x is equal to cos x, and x is equal to 45 degrees plus k times 360. The identities, we will be doing 2 identities from, these are not identities, this is how it's going to appear in the multiple choice, where they will give you the left hand side and it will be equal to one of the options. So you need to work through them and to see which option it corresponds with. So what we're going to look at is 2.3 and 2.3 and 2.7. Now 2.3, we've got sine 2a plus sine a all over cos 2a plus cos a plus 1. Now sine 2a, we know we got no options, 2 sine a cos a plus sine a. Now cos a, because they're already in its absolutely reduced form, you can't do much about it. Cos 2a, and you got a 1. How do we get eliminate this 1? Now if you look at cos 2a is 2 cos squared a minus 1 plus cos a plus 1. So that takes care of that. And then you'll notice your numerator, common factor, sine a into 2 cos a plus 1 all divided by cos a into 2 cos a plus 1, and that cancels. Sine a over cos a is tan a. So that will be one of the options, and the other options, one of the options could be cot a, which you wouldn't be able to get. And then looking at 2.7, 2.7, I've got cos 2a divided by cos of A plus sine of A all cubed. Now what I'm going to do here is I'm going to now look at firstly what can we get out of this. So if I look at this, I've got cos A plus sine A into cos A plus sine A squared. And for my numerator, I've got cos squared A minus sine squared A. And then that becomes cos A minus sine A into cos A plus sine A. And then that is divided by cos A plus sine A, which is one factor, into cos A plus sine A all squared, and that would cancel off with that, so it leaves us with cos A minus sine A, and the denominator will become cos squared A plus sine squared A plus 2 cos A sine A, or 2 sine A cos A. So the numerator will remain as is, and the cos squared A plus sine squared A is 1, and then we will have cos of A minus sine of A all over 1 plus, now 2 sine A cos A is sine 2A. Right, this topic here is trigonometric equations, which starts on page trig equations, which starts on page 44. Now if you look at the first one, it says solve for theta. Sine of theta is equal to root 3 over 2. Now you notice that it's a special angle, so theta is equal to 60 degrees. But we also know that sine is positive in the second quadrant, which means it's 180 minus 60, which is 120, will give you the same answer. Now the problem is there are many answers based on 60 degrees and 120 degrees, which will satisfy the same equation. So one of the ways of restricting the answers is to give the domain. So if the domain is given as 0 to 360 degrees, then those answers that we've given are correct. Now there is another more efficient method of representing the solutions of equations, and we will come to that. We use what we call the period of the trigonometric ratios. Now the period for sine of theta, the period for that is 360 degrees. The period for cos of theta, the period there is 360 degrees. What it really means, that if you had to draw the graph of y is equal to sine theta or y is equal to cos theta, within that 360 degrees it's a certain shape. Now this shape repeats itself. Now the period for tan of theta is 180 degrees. So we now can represent all the solutions in the general form and say theta is equal to 60 degrees plus 360k, where k is an element of z, or theta is equal to 120 degrees plus 360k, where k is an element of z. Now let's just take an example. When k is equal to 1, you will get 420 degrees, which we didn't get initially. When k is equal to minus 1, you'll get minus 300 degrees. Now when we substitute any integer value for k, we obtain the answers. It would be advisable to write all the solutions in general form and then do the restrictions as required. Now, it is going to be quite a challenge for anyone to set multiple choice based on equations. So what I've done is I've just selected one of the problems was 4 cos 2 theta minus 6 cos theta plus 5 equals 0, and then you will notice that cos 2 theta is 2 cos squared theta minus 1, so you will have 8 cos squared theta minus 6 cos theta plus 4 equals 0, and then you would actually end up with two answers. And so if you you take those two answers you require, you'll get cos theta is equal to quarter or cos theta is equal to half. Now you'll notice that in terms of the multiple choice we use the word only, and the only will not apply if you've got two answers. We are going to look at some of the trig equations of a different type, so you need to pay very careful attention. Two 2.1.1, we've got sine of 4x. If you cross multiply, sine of 4x is equal to cos of 2x, and then we know that sine and cos are related, they are complementary. So if you find the sum of angles, you should get 90 degrees. Now let's say these two angles are A and B, then A plus B is equal to 90 degrees. Now we also know that sine of 90 plus theta is a second quadrant complementary, and it gives you cos of theta. So which means that A minus B is equal to 90 degrees is another possible solution. So we've got 4x plus 2x is equal to 90 degrees, and we're going to have the k times 360, and so we've got 6 plus 360 k times 360 degrees, and that will give you 6x is equal to 15 degrees plus k times 60 degrees, where k is an element of z. And then if you're going to domain, you can just restrict it. So we're not going to spend too much of time on that, emphasizing that. Then I said A minus B must give you 90 degrees plus k times 360 degrees. And that means 2x is equal to that. X is equal to 45 degrees plus k times 180 degrees. Now if you test now 45, 4 times 45 is 180 degrees. Sine of 180 degrees is 0, cos of 90 degrees is 0. That's an answer as well. The next equation is given, and you will notice that we've got cos of 2 theta minus 1, so I must use 1 minus 2 sine squared theta to eliminate the minus 1. Sine 2 theta, we've got no choice. 2 sine theta cos theta, 2 times 4 is 8. 2 sine theta cos theta, sine theta times sine theta is sine squared theta cos theta, plus 1 minus 2 sine squared theta minus 1 equals 0, and then we will notice that what we will have is these 2 sine squared theta being the common factor into 4 cos theta minus 1 equals 0. So you got sine theta equals 0, or cos theta is equal to a quarter. And I mean, that is how the options are going to appear as well. It could appear like that because 1 quarter is not a special ratio.